Okay, so today we're looking at this practice problem from the digital SAT practice test number 8. And this one's a tough one. Which of the following expressions has a factor of x plus 2b, where b is a positive integer constant? So before we even get into it, I'd just like to mention b should be positive and an integer constant. Positive number, integer meaning, whole number 1, 2, 3, 4. That's going to be very important in a moment. So right off the bat, it seems like you might be able to use some tricks on this, maybe plugging in your own answers, maybe some sort of Desmos shenanigans. Unfortunately, this question is immune to basically any and all of that. The only way to proceed here is to do the question. So how do we begin? So they tell us that we have a factor of x plus 2b. So I'm just going to write that down right here. X plus 2b is going to be one of the terms we're multiplying. Now the first thing to notice is that every single one of these answer choices starts with 3x squared. So we know that whatever we multiply this by, we need to get 3x squared out of it. So how do we do that? Well, we have x right here. So x times what gives you 3x squared? Well, that'll be 3x. So this term right here has to be 3x. I'll even write that down right here. 3x squared. That's our two terms multiplied. The other thing to notice is that at the end here, we always have 14b. So same exact approach. We already have 2b. We know that's one of our things. What times 2b gives us 14b? Well, it's got to be 7, obviously. So we'll write down 7 here. Then we'll put down our 14b right here. That'll be what multiplies at the end there. So let's continue multiplying this out now that we have our two terms. 7 times x, that'll be plus 7x. And then 3x times 2b, that'll be plus 6xb. So this is our expanded binomial. And now you might be asking, why does this have a 6x plus or 6xb term and none of the answer choices on the SAT do? These are all just x. Well, it turns out what the SAT has decided to do is sneakily plug in the b just for the middle term. So once you plug in a b, you can obviously combine these terms for whatever that'll end up being. And the SAT has decided that the middle terms here will have a plugged in b, but the very end will not. So they don't give us that b at the end, but they do in the middle. So where do we go from here? So if we're saying that this is our expanded binomial, one of these answer choices should be that. And since 3x squared and 14b are the same everywhere, the only thing that's changing is these middle terms. I'll do a different color here. Let's do it in pink. These middle terms. And these middle terms should be equal to 7x plus 6xb. Whatever b ends up being, or whatever b ends up being, should be able to give us one of these middle terms. So how do we check that? So let's start with something like, let's start at b. Start checking at b. So we know that middle term should be equal to 7x plus 6xb. So let's actually set up that equation. 7x plus 6xb is equal to 28x. And we can start solving this. Subtract 7 on both sides, and we get 6xb equals 28 minus 7 is 21x. Then we divide both sides by 6x, and we get b equals 21 over 6. They'll simplify down to, you take away 7 from both, or 3 from both of those, you get 7 over 3. 2. 7 over 2. 7 over 2 is cool. It's a nice answer. Is that our answer? Well, 7 over 2 is not a positive integer. So answer choice B is not our answer. Then we keep doing this for the rest of these, but I'll just show you where this does work for our very last choice here, or just this. Um, 7x plus 6xb, and we're testing here answer choice D, which means we should set that equal to minus 49. Is that minus 49? No, it's positive 49. Equals 49x. Same thing here. Subtract both sides by 7, you get 6xb equals 42x. Divide both sides by 6x, you get b equals 7. 7 is a positive integer constant. So choice D is your answer. Just to show you that this does make sense, if we actually graph this, 3x squared plus 49x plus 14 times 7, because b is 7, we'll get some zeros here. One of them is this weird one, but then the other one is negative 14. And we said that one of our factors is x plus 2b, which means that one of our factors should be x plus 14. If we set that equal to 0, we'll see that x should equal negative 14. So we should expect a 0 at negative 14. So this is our answer.